guys, welcome to another lecture from Introductory Statistics. Today we will talk about continuous random variable. We've already seen there are discrete random variables. We've discussed discrete random variables in detail. Today we'll talk about the continuous. Now, what do we mean by discrete? What do we mean by continuous? So in discrete, we've seen that you have a variable which is taking certain finite values. It either constitutes finite set or can be listed in an infinite sequence of numbers per se. That's discrete random variable. In continuous random variable, as the name suggests, continuous. So your random variable can take values continuously. When that's happening, that means it's taking values in between, say, some interval. So you can write down variables whose set of possible values is an entire interval of numbers is continuous in nature. So say you have interval AB. For example, if we talk about time, time is continuous in nature. So if we have a certain experiment where we are taking time as our variable, we can say, for example, time spans between 30 minutes. So 0 to 30 becomes your interval where your time can take any value in between. That's what is continuous random variable. More formally, let X be a continuous random variable. Then the probability distribution, which we call PDF, that is probability density function. You will soon realize why we have this word density out here. PDF of X is a function fx such that for any two numbers a and b with a less than or equal to b, we have a specific thing. The probability that x, your random variable, lies in this interval ab, lies between anywhere between a and b, is actually the area under the curve fx dx between a and b. That is, suppose the graph of the function fx is something of this sort. Say this is your fx. And say this is a and this is b. And the area under the curve is this, right? So probability that x lies in this interval AB is this area, or integral a to b fx dx. So there are two properties for probability. For mass function, we had two properties. The same two properties will hold true here also. Number one, it's probability, so it has to be positive. So fx is always greater than or equal to 0 for all x, no matter what x is. And secondly, the sum of all probabilities have to be equal to 1, right? That's what we learned in discrete. Here, your probabilities are not sum, but that's area. So that means the total area, since the total probability has to be 100%, the total area between minus infinity to infinity, fx dx, has to be equal to 1. In here, try to understand if your random variable has been defined to be a certain function when x belongs to AB. So the area under AB will be equal to 1, the entire, because that's the only domain and it's 0 otherwise. So this is what it will be. Let's take an example out here. The direction of an imperfection with respect to reference line on a circular object, such as a tire, brake rotor, or flywheel, is subject to uncertainty. Consider the reference line connecting the valve stem on a tire to the center point, and let x be, your random variable x is the angle measured clockwise to the location of an imperfection. If it's an angle which is measured clockwise to the location of an imperfection, it's an angle. It could be any angle from 0 to 360 degree, right? You don't know exactly. That's why we are talking about probability here, right? So if it's any angle between 0 to 360, that means the probability of x to be in this circle has to be 1 upon 360. So here you can define the PDF of x, such an x, to be fx equal to 1 upon 360, where x, since we're talking about circular object, right? So circular object, the angle is 360, right? The total is 360. So 0 to 360, x can lie anywhere in between and it's 0 otherwise. So fx is greater than or equal to 0, as you can see, 1 upon 360 it is. And the total integral, is it equal to 1? Let's see. So minus infinity to infinity, fx should be equal to 1. This integral should be equal to 1. What is this integral in our case? It's minus infinity to infinity 1 upon 360 dx, right? Now, our random variable is such that fx is from 0 to 360. It is 1 upon 360, otherwise it's 0, right? So we will be considering the integral 0 to 360. So when I integrate this, 1 upon 360 can be out here common, and here you will have x, where the bounds are 0 and 360. So 1 upon 360, 360 minus 0 is equal to 360 upon 360, that is equal to 1. So this is correct PDF for sure. There's another way to look at it. Well, suppose this is x-axis and this is y-axis. So your fx would lie on y-axis, right? Now x can take values between 0 to 360. So I've marked that out here. Apart from that, what we know is that fx is a fixed value. Say here lies 1 upon 360. It's a fixed value 360 between 0 to 360. Now, what is the property for the PDF? The property for the PDF is that the area under the curve, area under fx, should be equal to 1, the total area, right? So if you observe, what is the total area out here? This rectangle. Now, what is the area of this rectangle? The area of this rectangle is length into breadth. So it is, you take the height, 1 upon 360 into, what is this length? This is 360. So 1 upon 360 into 360, which will give you 1. So yes, this is actually your PDF. Another way of looking that the PDF is correct. Now, suppose in here I ask you a question. What is the probability that x is between 90 to 180? As I mentioned, the probability is nothing but its area from A to B. So 90 to 180, area fx dx. We know what fx is. So 90 to 180, 1 upon 360 dx. So that is equal to 1 upon 360 outside, x, 90, 180 are the bounds. So 1 upon 360, 180 minus 90, that is 90 upon 360, that is 1 upon 4. 1 upon 4 would be the probability. Okay. Now, the same thing you can actually pick up from here as well. The area, if you want to find out the area between 90 to 180. Well, 90 to 180, the length is this. And of course, the height remains 1 upon 360. So from here also you can pick up that the area from 90 to 180 is the area under this curve. So the area of the rectangle where one side is 90 and the other is 360. 1 upon 360, so 1 upon 4 again. And that's the correct answer. This is what is continuous random variable. This is how you have to handle it. And there are various type of continuous random variable, the special types, which is something that I will be discussing in the lectures to come. Thank you so much.